All right, so welcome back to the Civil FE exam review. Um, Today in this video, we're going to be continuing our dynamics review, and we're going to be looking specifically at work, energy, and power. So if you haven't checked out any of the videos prior, right, ones like force acceleration, mass moment of inertia, or kinematics, for the dynamics review, make sure you check those out and master those as well. All right, so let's look at this practice problem. Number 1 says a rubber band is stretched by 0.2 meters. If the force constant is 100 newtons per meter, calculate the elastic potential energy stored in the rubber band. So what information are we given? Well, we're definitely given the distance stretched, right? Which is going to be your 0.2 meters. You're also given your constant force. Or the force constant, which is 100 newtons per meter. All right, we're trying to find the elastic potential energy. So find elastic potential energy. All right, what are the formulas that we need? Well, I know we need to probably be searching or looking at potential. I'm going to be wanting to look at potential energy. So I'm going to do a search in my handbook, my reference handbook, and do potential energy. Something came up. All right. So not this section. All right, so it's important to note that potential energy is denoted by Ti or T, and potential energy is denoted by V. So just something important to note. All right. So we got potential energy is equal to the elastic. So V is the symbol for potential energy. You got Vg, which is the potential energy in the gravitational field. And then you have Vee, which is here, denoted by the elastic potential energy. Okay. So I know that I will need Ve I know my formula is going to be Ve is equal to 1/2 Ks squared. All right, what is K? K is a constant. K is the constant. And it's the force in the spring. So it says a spring constant, K. So we're going to say our K is going to be our rubber band constant, which is 100 newtons per meter, right? Okay. And then what is S? Well, S for a spring, so it's a little different for a rubber band, but the force, okay, so the S is the change in length of the spring. So for us, our S will be the change in length for our rubber band. Okay, so S is equal to, and our change in length for the rubber band is stretch 0.2 meters. All right, so your potential energy is a little different for a rubber band versus a spring, but similar concepts. K is your force constant, and then S is going to be the distance that it is stretched. Okay, so we have VE is equal to 1/2 times my 100 newtons per meter times my S squared, or 0.2 meters. And I get this all to equal 2 joules. All right. So really, my units, it doesn't come out as joules, right? It comes out, my units actually come out first and foremost to be put it in my calculator really quick. 0.5 times 100 times 0.2. Yeah, so I get 2, but your units are going to be newtons, right? And then I'm doing meters squared over meters, so that's going to be Newton meters. So how do I get that to, how did I come up with, how do I get my final answer to be in joules? Well, let's look up. You can go into your handbook, go to the section where you're looking at your unit conversions. So unit conversions, and then within this, right, we have, see if we can find joules. Okay, so we know that, scroll over here, 1 joule equals 1 Newton meter. So we wanted to do our unit conversions. 1 Newton meter is equal to 1 joule, and therefore this is equal to 2 joules. Okay, so for my answer, I get B. I hope that you're enjoying this video. I just wanted to drop in and say, if you're looking to pass your Civil FE exam within the next 90 days, then you definitely want to check out the course that I've created. The video that you're currently watching gives you just a glimpse of what is in the course, and I have made it test taker proof. And what that means is no matter if you've been out of school for a while, or you just have trouble with some of the engineering concepts, if you study this material that is in the course, it will help you to pass within the next 90 days. There are also full practice exams. Yes, 110 question practice exams, along with review guides and study schedule templates to help you pass. And these are resources that I have created for you. So if you want to check out any of those, just head down in the description box below and check them out now. Now, to stay up to date on any new videos that I drop, whether it is more practice problems like in this video, or if you want advice and some extra tips to help you pass your Civil FE exam, Gonna want to make sure that you hit that subscribe button, turn on those bell notifications so that you know exactly when I post. And if you want to check out the next video, you can here.